Now, sometimes we have non-unique solutions to linear equation. It's not always possible to reduce a system of 3 equations and 3 variables to a system when the third equation contains 1 variable. Anytime you end up with a 0 equals some other number, that's inconsistent, no solution. That would mean no solution. Inconsistent means there's no solution. And if you end up with 0 equals 0, that's a dependent solution where you have, as with our two systems, that's where we have the infinitely many solutions. Now let's try this system. Oh, again we've got, oh, well look at this. We've got just one x in each of those. So let's take the top equation. Well, let's take the bottom equation. Let's take the top equation. Let's take the bottom equation times -1. So negative x plus y minus 3z equals -3. The x's go out. We have 2y minus 4z equals 2. Now let's take that top equation. Let's take the second equation, x plus 2y minus 3z equals 9, and take this bottom equation times -1 again. So negative x plus y minus 3z equals -3. The x's go out, and I end up with 3y minus 6z equals 6. Well, let's take this equation times 3. That will give me 6x minus 12z equals 6. And I'm going to take this equation times -2. That will give me the negative 6y, and you can see why I did that because I'm going to get rid of those, plus 12z equals -12. X's or y's are gone, so are z's. So I end up with 0 equals -6. That appears to me that there is no solution because I ended up with a false statement. So this would be no solution. Let's start this one. I notice that we have single x's again, so I'm going to start by multiplying the bottom equation by -1. So negative x minus 4y plus 2z equals -14. Now I'm going to take that equation and add it to the top equation. So x plus 5y minus 2z equals 5. The x's go out. I end up with 1y. Oh, the z's go out. And it equals -9. So I have a y value already. Y equals -9. Now I can take that and put it in I'll put it in both of these other equations. So putting it here, x minus 27 minus 2z equals 23. And in this equation, of x minus 36 minus 2z equals 14. Combining like terms, end up with x minus 2z equals, adding a 27 to both sides, equals 50. And here I'll have x minus 2z equals 50 again. Subtracting, so I'll change the signs, all of these signs. I'll get up with 0, 0, 0. So 0 equals 0. Since that is true, we have infinitely many solutions. Infinitely many solutions. That's what we have. Now I'm going to go with this equation and come down and solve that for x. So x equals 2z plus 50. And my answer choices are going to look a little different here. So I have infinitely many solutions, but x will equal 2z plus 50. Y will equal negative 9. And z will be any real number. So this becomes my solutions.